Alrighty-o. Hello and welcome to another Solana tutorial. Today we're gonna talk about the compute budget program. This comes in two parts. First we're gonna talk about compute and then we're gonna talk about prioritization. So what even is compute? What are compute units? What is that so-called compute budget? And how do we change that? And then priority fees and how we can prioritize our transaction. And I might make this a separate video depending on how long I speak about compute today. So let's get started. It's so good to make a video again. The past 3 weeks I was busy with a project. Compute. What even is that? So for a computer program, two things are important. Compute and storage. Calculations and memory. Changing data and persisting data. The second part, the memory part, storage on Solana, is done with accounts. We've talked about accounts. Accounts hold data. Those are the bytes. That's the state of the Solana blockchain. That's the memory part. But then compute, that's what we need to work with that data, to modify that data, to write that data. Compute is what the CPU, the processor, is doing, and memory is the memory, the RAM, the hard drive, whatever. So we have compute and memory. On the Solana blockchain, the compute is performed by the validators who execute transactions. So when a transaction gets executed, then the validator does some calculations. It performs the instructions of the programs, and that needs so-called compute. I don't want to go into too much detail. Essentially, every low-level instruction has a certain value associated with it, how much compute it takes, and then basically we keep track of how much of those compute units we have spent in that transaction. I think I want to do less talking and do a bit more practical stuff, so let's get to work. Because if I'm just talking, this is too abstract, so let's just have a look. Do I want to use Playground? Yes. Because Playground has this nice new feature of the Rust analyzer. Let's do a function compute. And also here we see it again. This here is the memory part and this here is the compute part. So what do we store and how do we calculate some stuff? So I'm gonna make a compute instruction. And in the beginning, we're not gonna compute anything. We just say, okay. I just love my vanity addresses. I cannot live without them. There we go. Then let's build this. And let's deploy this. And then we're gonna manually build ourselves a transaction that calls that, because I'm too lazy to do it the anchor way. And the program is this, not my rifle program. So essentially I'm just, oh fuck's sake, I'm gonna do that manually as well. Doing stuff manually just gives me more control. I love it. I love control. Okay, so essentially what I'm doing here is I'm building myself an instruction to a program, and I'm calling the compute instruction and I'm passing in some data that I don't use yet. Build myself the transaction instruction, create myself a version transaction, and now we can simulate it. And then we can actually execute it as well. And let's do that. So great simulation fail. Oh, haha, I don't have any SOL on my account, that's true. We see units consumed 0, account not found. Okay, yep. That makes sense. Okay. The one thing that I don't like about Playground is that I can't easily copy and paste in here. But otherwise, Playground is pretty nice. So I should now have some SOL on there. There we go. And now the thing is gonna look different. There we go. 888. What a nice number. Compute units consumed is 888. Not that I'm a fan of 88, just saying. With my nation and 8 being aged, that it might... If you don't know what I'm talking about, that's fine. That's then good. Yeah, so we can also have a look at that on the Explorer. We're not going to see much more here than in our simulation, but a little bit. So, for instance, we see that the fee... Again, I'm going to make this a bit bigger for you. The fee was 5,000 lamperts. That's the base fee. We're going to come back to that when we talk about priority fees. And compute units consumed 888, which is not a lot. That just comes from some anchor checks that are being made because, you know, checking which instruction to call and stuff. But less than 1,000 compute units is untypical for a transaction, but it's also untypical to, not do anything in a transaction. So because all we're doing is saying okay and that's it. So 888 of the 200,000 compute units are consumed. And here we already see we have a cap for how many compute units we can consume in one transaction. Why the hell do we need that? Well, glad you asked, students. Since Solana smart contracts or programs are Turing complete, if that doesn't ring a bell, basically they allow for recursion and or loops. We cannot guarantee that the execution will actually end at some point. That's the halting problem, in case you're aware of that. Short version, given any program and its input data, we cannot say if that program will ever stop. So also a validator can't know if what they're executing will ever stop. Also, even if they could say that, it might just take a long time to stop. And time here is critical because if it takes too long to compute, then our slot time is over and we cannot produce a block if we didn't manage to execute. So we limit the amount of compute that we allow per transaction. I think there's also a limit how much compute we can fit into a block, but I would need to read up on that further. So yeah, and that's why we have this compute budget limit, which just allow a certain amount of compute to be used. Because once that compute is used, we just say, well, it's over. You failed. And like in Ethereum, you do pay for the gas fees still. It's your fault that the program didn't complete. I still had to calculate all that stuff. So let's simulate that first thing that I was talking about, non-stop. But that means something different. Will Rust allow me that? What do I estimate? 10K? Oh, right, it's not a for, it's a while. Could also have made a for loop with that I, but whatever's. Deployment successful. Let's execute that one more time. Again, our simulation gives us an instruction error. Can't stop me, consumed that many out of exceeded CU meter, compute unit meter at BPF. So that's the Berkeley packet filter. That's the bytecode. At this instruction. So the bytecode instruction, they increase the compute units. And this particular instruction in the program triggered the 200,000 and first compute. So it increased over the 200K and therefore this transaction error is returned. So we cannot send that. Program failed to complete is the name of the error. It's an instruction error, which is a transaction error, and the name of the error is program failed to compute. Yeah, so we can't look at that on chain, can we? Because simulation already failed. Can we force it? Just ignore that it would fail. Can I still pump it out? My question essentially is that put in a block if it's hit the validator? And the answer is yes, it is. Because it's just a normal error. The program doesn't return an error, but the runtime is checking that, I guess. Well, it calls it program error, so I mean, in a way it is the program, but it's not that the program made the instruction. Well, indirectly it did, but because it hit the compute limit. So there. One more time. Exceeded compute unit meter at PPF instruction something something. So if we force that out to the validators, they will execute it and they will charge me for it one time the base fee, but none of the state will be persisted because the program didn't finish or the program didn't finish in time. This particular program cannot finish in time because literally it will never finish. My 10K iterations apparently were too many. Let's see how many of 1,000 we get. Why do I multiply I by 1,000 here? That's stupid. And now we will see we get through a bit more than 2,000 iterations of our loop, basically just increasing a counter. We can do that 2,000 times, but then we're stopped at some point. So we reach the limit. But what if I wanted to get to 3,000? What if I had a program like this? And that might be a bit arbitrary, but let's say you're transferring 2 PNFTs, then you'll also reach the limit of those 200,000 compute units. Because a PNFT is just a massive construct. I know that from my project where I was transferring several P NFTs in one transaction. So not only did the transaction size limit me, but also the compute. That's why I learned about this, and that's why I'm now teaching you. Anyway, we deploy this version, and we would really like to have this instruction finish. We would really like to get to the 3000. What can we do? Because for now, we're limited. We cannot execute that. It still fails after 2000. So what can we do? Well, glad you asked again. We can call an instruction on the compute budget program. Let's check some theory. Compute budget. To prevent the abuse of computational resources, each transaction is allocated a compute budget. Yes, obviously we can't allow everybody to compute as much as they want, because then we won't be able to fit all of that into a block. Validator will have to calculate too much. As the transaction is processed, compute units are consumed. This is a complicated sentence to comprehend. So a transaction has instructions, and the programs of those instructions perform operations like executing SBF instruction or calling syscalls or doing something else, and all of that costs compute. When a transaction consumes its entire budget, the runtime halts the transaction processing and returns an error. Interesting. Here we have what causes compute units, what requires compute units. Executing an instruction, the low-level instructions like increase the value of this variable, do an arithmetic computation like a plus b, check if something is true, jump somewhere else in the execution, those sort of things. If you want the entire list, there you go. We have load operations, load into register, but that's all very, very low-level stuff here. That's why I don't really want to go into that. Store from register, store from immediate operations, so calculate something, store it to memory again. Arithmetic operations, jump operations. Yeah, that's pretty much what I was already saying. So yeah, and here we have the descriptions of the individual ones. Again, if you wanted to see all of the instructions, you can. However, this is not really relevant since we're not coding on that level anyway. For us, it's enough to simulate and see how many compute units what we are doing used, and then we can, estimate how much we need in total. Fun fact, you can also log how much compute you used. Use the system call sol log compute units to log a message containing the remaining number of compute units. Let's see. Okay, where do I find that? Yes, that's it. I just add this sol log compute units, and then it will tell me how much I still have remaining. There we go. Program consumption, that many units remaining, that many units remaining. So the first, but why did the first 1000 not compute more than? So in the beginning, we have almost a 2K left. Then after the first 1000 iterations, we still have 160 something left. At 2000, we have only 29. Yeah, interesting. The first 1000 iterations are way cheaper than the second 1000. And see, that's why this is useful. You can use that for debugging. However, I would highly recommend that for a production program, you remove all of those logs again, because they also cost compute. Anyway, that's how you log how many compute units you have remaining. Let's get back to those are the instructions. Passing data between programs, so with CPI, that also costs us compute, and doing syscalls like logging, even though that's not like an arithmetic operation or something, but that also costs us compute. That's why having too many log messages might also not be ideal, especially if you're already low on compute. Current compute budget can be found in the Solana program runtime. There, compute budget. There we see all of those costs. Yes, here. There we see the max invoke depth. I think that's the number of CPIs that we can do. We're limited to 4. We already saw that in a previous video. We're gonna have a look at there. Haha. Again, this is quite small for you, is it not? So, and those are the values that I wanted to get to. So, the default compute unit limit is 200K. The maximum compute unit limit is 1.4 million compute units. So that's the maximum compute units that I can request. But how do we request those? Well, it's just an instruction on the compute budget program. Let's have a look at that. The compute budget has the following instructions: a deprecated one, request heap frame, set compute unit limit, that's the interesting one. And then later we'll also use that for priority fees, the set compute unit price. That's why it's all connected. And I can also set loaded accounts data size limit. But let's stay with that. The set compute unit limit. It just takes a U32, and that will be the compute units. We have already seen that the maximum that we can request is 1,400,000. So let's do that. Let's request more compute. If I remember correctly, the compute budget program, it has a set compute unit limit, which returns a transaction instruction, which is perfect. And that just takes parameters, the units, and here we can put in how much we request. Let's say 1 million. To make it easier to read, I'm gonna write it like this. And this gives me the set compute unit limit instruction, which I'm just gonna add into my instructions. Cool. So with that instruction added, can I execute this program now? I mean, execute, yes, but will it complete? Yes, it does. It is done. And it's still got almost 700,000 compute units left. So a bit more than 300,000 it used. There, 303,000 with those 3,000 iterations. Maybe the compiler did some optimizations for the first 1,000 iterations here. That could be, because the first 1,000 are cheaper than the remaining ones. Anyway, let's have a look at that on chain, see what changed. We are still just paying the base fee, so increasing the compute units does not cost us anything yet. And we see, okay, first instruction, we set the compute unit limit with the compute budget program, which is one of those special accounts, as you see at the address, you know, compute budget 111111111. That's a special address. So that program already existed from the beginning of Solana. You can't create that afterwards. And the assigned program ID is the native loader. And that one is owned by the system program. Okay. And the system program is again owned by the native loader. Well, the native loader is just assigned to nothing, to 0000, but that just happens to be the system program address as well. I think that's how it goes. Yeah, anyway, should we get sidetracked real quick, even more? I always wondered what would happen if I sent something to the system program or to the compute budget program, because it has one Lampert there. And wouldn't it be funny if there was more? Can I transfer 0.001 to the compute budget program? No, transaction loads a writable account that cannot be written. Okay, so this account cannot be written to. Okay, cool. Learn something else. Nice. Cool, but our program managed to finish its 3,000 iterations because we gave it enough compute. Now, what happens if we request too much compute? Just so you've also seen that error. Okay, we don't even get an error, but the maximum is still 1.4 million. So even if we request 2 million, we just get 1.4. Nice, nice, nice. Good. I think it's time to talk about priority fees, because it is connected. To understand priority fees, you need to understand the compute units. So that was a good start to now talk about priority fees. So a Solana transaction can include an optional fee to prioritize itself against others, known as the priority fee. Paying this additional fee helps boost how a transaction is prioritized against others, resulting in faster execution times. That's how I should read everything. How the prioritization fee is calculated. No, never mind. But this is interesting though. How do we calculate that priority fee? By multiplying the maximum number of compute units by the compute unit price. That, by the way, is measured in micro Lamperts. Because, you know, compute units, there are quite a few. So Lamperts doesn't have a big enough resolution. And we also don't want to talk about mini compute units or something. So that's why we chose those. Anyway, so point is the maximum number of compute units with a compute unit price. So that maximum number is that number that we are setting here. So that's the limit, the maximum of compute that we are requesting. And that's why here it makes a difference suddenly, because so far it didn't make a difference. I can arbitrarily set my compute unit limit to 1.4 million in every transaction, and it doesn't cost me anything. I don't have a disadvantage at all. But when using priority fees, then yes, I actually have to pay for that. And I have to pay for what I request. So the priority fee, the more the transaction wants to compute, the more it has to pay in priority fee to reach the same priority. Right, so how do we set that? There is yet another instruction on the compute budget program, and it's called the set compute unit price. If that is not specified, so if there's no instruction with the set compute unit price, then it will stay at the default, so there's no elevated fee and the transaction will have lowest priority. So no priority fee if that instruction is not provided. Now, it doesn't say that I need to do that in the beginning. In fact, let's also test that. Could I just first actually use my compute and then set the compute limit? Would that also go through? I've never tried that, but that's how we learn. Yep, that would also go through. So I can even, let's compute, it starts with 1.4 million, even though I didn't even call the compute budget program yet. That is then only called later. But apparently the runtime analyzes the transaction, finds those, then sets the maximum number, and then only starts executing the transaction. So I can put them anywhere. So I don't need to put them at the very first spot, which is also important because at the very first spot, sometimes I need to have my nonce advance. I also had that at my project. Cool. But for some reason, I still find it nicer to do that in the beginning. Actually, no, I do not, because then the explorers will always say, oh, compute budget program, if I look at the instruction. No, that's not what it does. That's just the first instruction. But that's actually an explorer's fault. But it doesn't matter. It doesn't matter. Let's do it as the first instruction. Right. And then we create ourselves another set price instruction. Also in the compute budget program, set compute unit price, which again just takes a price in microlamperts. So they called that variable here microlamperts, such that it's clear that this is in microlamperts. And I could specify, lol, the minimum. I want to pay 1 microlampert per compute unit, just so I get above all the other transactions that do not specify any priority fee. So let's also put that in as an instruction and then execute that. We will not see any difference here in the simulation. It still takes the exact same compute units, which is fun because apparently this execution here is free. And our loop is still executed. So here we do not see a difference. However, if we have a look at the transaction in Explorer, then we will see that something did change here. Not only did I have to pay the base fee of 5,000 lamperts, no, I also paid 2 more lamperts for the prioritization. So 2 lamperts priority fee. Why 2? Because it's rounded up from 1.4. 1.4 million compute units with a price of 1 microlampert cost me 1.4 lamperts, because million and micro cancels out again, both 6 zeros. That's how it's calculated. Essentially, take that number, multiply it with that number, divide by a million. Or take that number and divide it by that number multiplied with a million. Which is literally the same, because division and multiplication is, what's the mathematical, there's a term for this. Commutative. Okay, commutative. Okay, good. Mathematics. Anyway, point is, we pay 1.4 lamperts here in addition. That little bit of priority fee probably won't get us far unless everybody else uses no priority fee, but they might use a higher fee, right? So they might be like, I can afford another 1,400 lamperts, so they set the price for micro lamperts to 1,000. Now calculation exercise for you. How much do we pay now? How much in priority fee and how much in total? If you said 6.4, then you are correct, unless I am wrong, which I am not. Well, 6.4 thousand, of course I meant 6.4 thousand. 6,400 lamperts we pay now, because the 5,000 in base fee and the 1,400 in priority fee. We can go as crazy as we want to. If we are rich, we can be like, I got that money to pay for priority fees and pay a lampert per compute unit and then request 1 million compute units. How much are we going to pay now? We pay, well, 1,405,000 lamperts. Yep, there we go. So that's 0.001405 sol. That's already the price of a small data account. And then I want to come back to the compute unit and memory stuff. They're both priced in sol. For the compute units, we pay this also to prioritize because if other people pay more for the compute, then they get the compute. It's a resource. Rent, however, is still static because there's no limit in rent. So there's no priority fee for rent yet. Maybe the rent will also be dynamically priced at some point. But yeah, in rent, that would already get us like about 70 bytes or so for rent exemption. So for storage on Solana. And here for compute, but very prioritized compute. Usually a transaction is not that expensive. But hey, if you want to make your transaction that expensive, you can pay 1 sol for your transaction if you want. If I had enough definite sol, I would demonstrate that now. Nah, you'll just have to believe me. Definite sol is too valuable. I'm not gonna pay 1 sol in priority fees for no reason. But that already brings us to be careful with priority fees. Because if you accidentally set the wrong value here, then you're suddenly paying an entire sol and you cannot get that back. I think somebody did that accidentally before, because we had somebody pay like a sol for priority fee and Toli was tweeting, why do you do that? I'm expecting that was not on purpose. Okay, you know what? I want to demonstrate because it's just so fun. I want to see this. Let's get ourselves a proper airdrop. There we go. Now I can afford 1 sol priority fees. So let's do something stupid that I do not recommend that you do ever, because why would you pay that much? Unless everybody else also pays that much and then we're on Ethereum. Well, not quite, but almost. There we go. That's how you pay 1.4 sol in transaction fees, which is highly stupid. Especially because you wouldn't even have had to pay that much to get that priority, because you only consumed 300. So you totally overpaid here. Not just in comparison for the priority, but also you requested too many compute units. I requested too many compute units. Let's take that responsibility. Of course, I could just set that down to 400 just to be safe. It's 304,000. But I'm going to be conservative and give you a bit more to be flexible. And if I decrease the compute unit limit, then I also decrease what I pay in priority fee. So what I pay in transaction fee, while maintaining my same priority. Although don't quote me on this, I'm not actually sure how that priority is actually. I mean, the validator would be stupid not to take my transaction. No, actually the validator would be smart if it would take mine, because I'm totally overpaying for it. So it would rather take mine because it gets more and it still has less compute. So in a way, it's the complete opposite of what I was just saying. If I was a validator and I got once 1.4 and once 0.4 sol, and not all of that fee goes to the validators, but I think a bit of that goes to the validators. So another part is burnt or something. But yeah, a validator would be smart to take the other one and not this one. So I'm not actually sure. Maybe it's just the calculation. So that there's still I still have some open questions here. Or maybe it's the maximum compute that you can put in a block calculated by the requested units and not by the actual consumed units? Maybe. Then it would make more sense again. But anyway, point is we can just consume 400,000 compute units or request 400,000 compute units. The program still goes through, so we can still get all our 3,000 iterations, still consume the same amount, but we pay less even though we set the same price. So obviously it makes sense to request as little as possible in terms of compute units. I still have that question, but let's go through it. Maybe then it becomes clear to me. Why would I optimize for compute units? What is the difference here? So in other words, why is that better paying 0.4 sol? Okay, maybe let's not do it with those stupid numbers. First of all, because I'm going to run out of definite sol, but also because I don't want to teach you to use those numbers. I want to set a realistic example here. What's realistic? Same order of magnitude. This would seem realistic to me. 4,000 lamperts that are paying priority fees, so 9,000 lamperts in total. Oops, no, I'm one of 400, of course. I'm stupid. 400. Well, okay, maybe then I increase the price. I don't mind. Add another 0. Now we are at 4,000 lamperts for priority fees. So I'm paying 0.000009 sol. There we go. That's what I wanted to achieve. Okay, why is that better than if I request, say, twice as much compute, but only pay half of the price per compute unit? Because then I also pay the same thing and I also consume still the same amount of units. Why would a validator prefer this transaction over the previous one, over this one? They're both paying the same and they're both consuming the same. I'm actually not sure if a validator would prefer either of them or if it says they're both equal in priority to me. From an economic perspective, I think if they use the exact same amount of compute, then a validator would prefer the one with higher fee. However, okay, it's starting to make sense. Hold on, I'm getting there. When deciding on which transaction to take into my block, I don't know the actual compute units consumed yet. Even if the block is actually constrained with actual compute units, I don't know how much actual compute units the transaction needs until I have executed it. So I would need to execute it. So if I execute both of them, and then be like, aha, okay, they both pay me the same and they both use the same compute units, I can take either one of them, they're equal. If I do not execute them, so if I just look at the transaction, then I will of course want to take the one that sets a higher price. Here, this one, because it has the higher price, 0.01 lamperts per compute unit, as compared to this one that pays less, because at that point I do not know how many compute units it actually takes, and this one could theoretically take twice as much compute. It does not, but I don't know until I actually executed it. So when deciding, when prioritizing, I obviously calculate it with the requested amount and not with the actual amount. Okay, now it makes sense. Thank you for explaining that to myself, Andy. Well done. Learning while doing. So we talked about priority fees. Brave did update and all my wallets are gone. Let's send 1 sol to myself. Solflare was the first wallet where I noticed it. They add priority fees to every transaction where they can. If it's pre-signed, then they can't. But if they can, they add those instructions, and here we see they stay with the standard 200K and they price it with 55,000 microlamperts per compute unit. So that's their pricing. That's what they deem normal, just to get a reference. So all of the wallet transactions that come from Solflare wallet will have that priority. So we, with our 5,000 priority, will still be further back in the queue to every transaction coming from a Solflare wallet. If we wanted to outprice the Solflare wallets, then we would need to go up to this sort of pricing, which then again also, even if we are at the correct compute units, there now we're at 0.029, so that's 29,000 lamperts. You know, a normal Solflare transaction also pays 0.00016, so 16,000. So that's a bit more than 3 times the base fee. 1 time the base fee and twice the base fee plus a little bit for prioritization. Let's also check out Phantom, because why not? Let's see how Phantom does it. Oh, Phantom prices them even higher. Or is that lower? No, that's lower. 4, 5. Yeah, that's lower. Phantom prices them lower. Phantom prices them at 8,000 microlamperts. Interesting. Interesting. So that's just wallet choice, really. In my opinion, you wouldn't need to add any of that unless the network is congested for the state that you want to get to. So I would just try it with 0. And if it doesn't go through, then I add a priority fee. That would be my strategy. But also I'm greedy. Yes, even for those little amounts of lamperts. And it's less usability, right? The wallet wanted to go through the first time in any case to have the best usability, so it makes sense that they do that. However, actually, my preferred way of doing this is the backpack way, because here I can then... No, I cannot. I thought I can manually add priority fees in backpack. Okay, never mind. We just wanted to get some idea of what a normal price for compute units are. So all Solflare wallets have 55k, Phantom wallets seem to have 8k. So that ballpark is what we're probably aiming for. Unless we're really arbitraging and really want to get our transaction through, we might, you know, increase that. But most normal transactions will be in that range. Also, no, most transactions probably will be in the range of 0, because for now, even without a priority fee, I can get my transaction in. Solana has enough block space to fit all of the transactions in, even if we don't prioritize them. But that's just the one aspect, getting my transaction into the block, that I can also manage with 0 microlamperts per compute unit in priority fee. The more interesting aspect of priority fees is state auctions. When we actually compete for some state, like you want to write to an account, I want to write to the same account. Who goes first? Well, the one with a higher priority. You know what? I think I want to end it here and continue the conversation about priority fees in the next video. I mean, we have already discussed priority fees and you have the basic idea of what they are. Not so much what they can be used for actually, but how the fee is calculated. We know some basics now. We can put in a priority fee and pay more in transaction fee to get priority, whatever that means. And whatever that means, we're gonna find out next time, because Andy is getting hot and has been recording for 4 hours, and that's enough for a video. So yeah, I mean, I hope that you learned a little bit still about compute, what that is, how to increase compute units. I mean, that's a very important skill to have as a Solana dev. If you can't do that, then you basically can't work with NFTs anymore. Oh, I could go back here. Yeah. Yeah, I don't know. Just keep learning, enjoy your life, all the good stuff. And then come back to watch my next video about priority fees. And there's also one about a project that I did that I cannot talk about at the moment. Anyway, go here, watch a video that YouTube recommends to you. Go here, watch, I don't know, another video that I recommend to you. And then go subscribe, like the video, and I shall see you in the next one talking about priority fees. Finally, where we're actually gonna find out what they're actually used for, because for now it seems like they're pretty pointless. Except for paying more, I didn't really see the use case yet. And that's gonna change in the next video.